Essentially, this is an explanation of a very old, as in Egypt old, building technique that began in the United States back in the 1800s. In Nebraska, which is where you get the name the Nebraska-style house. It's actually a type of building technique. They had no trees. So you could obviously not build a house out of wood if you didn't have any trees in the first place. What some adventurous farmers decided to do was create their homes out of mud and out of hay. We don't use hay anymore because animals actually eat it, and that's probably not a good thing for your house. Get enough problems with termites and wood without having mice decide they want to eat your walls. So there's a major difference between straw and hay. Hay is actually something that is grown to feed livestock. Straw, the only use in the livestock industry is bedding, because nothing will eat it. It's also a very dense material as far as the cellulose that it's grown. Basically, it grows in tubes. The tubes trap air. The air becomes an insulator. And when you compress this in modern baling techniques, you end up with a huge brick that runs an insulation value far and above what anything can possibly come close to. The walls in a standard home and in this building as an example, there's an R rating process that's used by industry to gauge how much insulation value a building has or a material has. The windows here, double pane, you're probably looking at about an R6 rating. The walls, you're probably anywhere between an R12 and an R16 if it's a traditional building technique. Straw bale structures, when they're built, are generally running anywhere from an R48 to an R60, depending on the density of the bales, the type of straw that's used, because there are many, many, many different types. You have rice, you have wheat straw, you have many different agricultural products that are grown for the fruit, which, like your Cheerios, they're an oat base. Your Wheaties are a wheat base. Essentially, they're taking the top off of it, turning it into your cereal, and then the rest of it gets thrown away because it's useless. You can't eat it, nothing really can. And so you end up with this trash. A large percentage of the time, the trash is simply thrown away, which is not good. Or it is burned, which is really, really not good. What we do, and what a lot of people have actually moved towards now, is we build with it, so it doesn't get thrown away. Here in Kentucky, we're dealing with an enormous amount of waste product because of the farming that's done here. So this house is an example that we're building right now. We ordered it from 40 miles away. And we almost bought from Indiana. To give you an idea of how easily accessed this material is, it's $4 a bale right now. And that's because there is a shortage, because of the drought. They're using this to make beds for cows. All they're doing with it. So we are taking it and actually building. This has been done in New Mexico, in California, in Nebraska, in Arizona, many different places throughout the United States. They're already building this. They've passed the codes. Everything is kind of already worked through the system. We're now making it available here in Kentucky, starting in Louisville. Right now there are 2 existing buildings in Kentucky that are straw bale, and obviously they're not up to code because there is no code. We have introduced the codes into City of Louisville so that it becomes a bona fide building practice, because we feel that you cannot really make something mainstream until the city actually recognizes it. And that's what we're in the process of doing now. Get this back so that I can start from the beginning. And this is my standard spiel. If you have any questions as I go through this, please. Essentially, this is telling you about the insulation values of straw bales. It is very inexpensive. As I said, it is typically a waste product that is destroyed in one way or another, or in some cases tilled back into the field so that they can replant one season later. It's why you'll drive down the road next to farms and you're going to see yellow fields. Essentially what that is, that's the straw. They've got nothing else to do with it. So it's sitting there until a machine comes by and grinds it back into the earth, and then they'll be able to replant in a season. You can create a fallow field by putting too much straw into the soil because it doesn't break down. The properties of the material itself are not conducive to being biodegraded unless you purposefully want to do that. You keep it wet, over a long period of time, it will degrade and it will become usable soil. But most of the time, it's actually gathered into large bales, whether it's the huge round bales that you see on the side of a farm field or the square bales that are used in construction. They're very, very tight so that they don't take up much space, because the whole idea of this is let's get rid of it. Essentially, they don't want it. The value of it comes in many different ways. One, a typical 2,000 square foot home, you're dealing with a cost of anywhere from $130 to $140 per square foot for the building materials for that unit. Typical straw bale house, $30. And that's on the high end. That's what it's costing us with this one because of the cost of the straw that's available right now, because we're having a bit of a shortage. Straw also is totally, well, not totally, nothing is totally fireproof, but it beats any other material on the market. They did tests in California at Berkeley where they built a full straw bale wall and put it in a blast furnace. This is not anything amazing because they do this with all materials before they can do a fireproof rating on it. It took well over 2 hours for this wall to even suffer any damage, and at that point it started to smolder. With a standard construction on a wall, it took about 40 minutes for the thing to be engulfed in flame. So you're dealing with a much higher level of fireproofness, and it's actually a physical rating that is done by the federal government. You're dealing with a low moisture movement within the walls. You want some, no matter what you're building. You need it because you don't want moisture to sit in the wall. You want it to move out of your walls, whether that's traditional construction or whether it's straw bale. It's a reason that most straw bale houses you'll see later are plastered. They're using often an earth plaster, which allows breathability within the home. This does not mean air necessarily moves easily, because you don't really want that in a sealed home, but it does allow moisture to move through the walls. What we're ended up doing is using a lime-based plaster, which actually will, over 100 years or so, convert directly into limestone. And by the way that that works, it will absorb the carbon dioxide that is in the room, and it will, through chemical reactions, actually become limestone. That's why sometimes you'll go into a newer straw bale home and you'll smell ozone when you walk in, because the walls are going through a chemical reaction continuously. So an unused, unaired room, you can actually have a buildup of ozone within that room.